All right, folks, it's Bass Action, back in action here. In this video, we are going to go over some basics of logarithms. We're just going to hit kind of some high points of some main examples, and then we'll do a lot more practice in class. So for starters, before we can get into any examples, let's just first remind ourselves what the graph of a logarithm looks like. I've got an equation here, and I've got a graph. Now, what I want you to notice is that we have this vertical asymptote, which means we're going to have domain restrictions with logarithms. So that's going to be a new thing that we're adding in this so far this year. That means that on our logarithmic graphs, our graph will be either completely on one side or completely on the other side of this vertical asymptote, assuming it's just a basic logarithmic graph. Of course, as we've seen, there's always exceptions. Now, when I look at this equation, a little review of how to read this, we say the word log, then we'll have a subscript here, and whatever that is, that's read base, so log base 2. Then we have whatever follows this logarithm called the argument, and we'll read that as an of. So this will be log base 2 of x. Now, we want to understand the domain of a logarithm, and as mentioned, it has a vertical asymptote on one side or the other the graph will be. So our domain for this function, what we can see is going to start at 0, but not inclusive of 0. So we'll have a parentheses, and it's going to go forever in this positive direction, so to positive infinity. Jumping over here, we're just going to do a couple quick examples. We've done a lot with logarithms or with domain, so adding in our logarithms shouldn't change a whole lot for us. We're going to look at this argument. That's the part we're concerned about. That's going to create a restriction. We'll go ahead and give our mark on the number line where that argument equals 0. That'll be 10. We'll give it an open circle because, of course, that's where the asymptote will appear. And then we'll test on each side, just like we have been doing all along. We can see on this one that on the left-hand side of that argument, it's going to give us positive values. On the right-hand side, it'll give us negative values. So our domain is going to be negative infinity up to 10, and again, parentheses on each side because of our open circle. Looking at this more complicated version, we've got a more complicated argument. So we've got two values that we're going to put on our number line. We're going to find where the denominator is 0, and that's going to be at 4, and it, of course, is open partly because it's inside a logarithm, but also because it's the denominator of a rational function. The numerator of that rational function is going to be 0 at a negative 3. That's also going to be open this time because it's inside the argument of our function and it's of our logarithm, and it's going to make that 0. So that's where we would have an asymptote. Now we're going to go ahead and we're going to test on each of our intervals. If we're on this far left, we're going to end up with a negative over a positive, and that's going to be negative, so we're going to throw that part out. If we're in this middle interval where x would be 0, these will drop out, and we end up with positive over positive, so we're going to keep that. And on the far right, now we're going to get positive over a negative, so that's going to get thrown out. So our domain is negative 3 to 4, parentheses on both sides. Next, we're just going to take a quick peek at evaluating logarithms without a calculator. Now, there's going to be a lot more examples we'll do with this, but this is just to kind of refresh your memory. First of all, common logarithms will have a base of 10, so we can write them as log base 10. That'll be a little subscript, let's say, of x. But we can also write this in a simpler way since these are common, so we have an easier writing of them, and we can just say log x. So on a common logarithm, we don't have to write the base. A natural logarithm has a base of e, so that's going to be log base e of x, and we'll do some more work later to understand better what e is, and a natural logarithm has an easier writing for that one as well because it's used so often, and it is going to be written ln and then x. So if you see ln, that's the same as log base e. The next thing we're going to look at, and again, these are just quick reminders, we'll do a little bit more work to reinforce why these are true, but the log of 1 will always equal 0. And again, we're going to do more work with this in class. The log base b of b, so that would look like, I'll just go ahead and write that out, log base b of b, that is always going to equal 1. So we're going to use these ideas later, but we're also going to do some more work to refresh your memory as to why these are true. Now, there are some shorter versions of how to do some of these problems. I'm going to show a longer version here. I'm not going to do all 4 of these in the video. I'm just going to look at a couple of them, these two specifically over here. So what we want to do if we want to evaluate these, if we can't quite remember, we're going to set this equal and we're going to write ANS for answer. We are never going to make this be an X. We do not want to insert a variable into the problem because that can definitely complicate things for us. The reason I want us to see this is, and we're going to go ahead and we're going to draw a little line here so we can see what this would look like if this was on a printed paper that had lines. It'll help us visualize this subscript for the base. What we're going to do is we're going to switch this from a logarithmic form to an exponential form. And what we'll do is, I always tell my students, find that base and circle it or put your pencil on it, and then we're going to move this around like this. So the base of our logarithm is going to become the base of an exponential, and on the other side of the logarithm is going to become an exponent now. So this is going to become 1/2 to the power, and it's just going to say answer, and that's okay. And then we're going to come back around, and whatever the argument was is going to now be on the other side of our equation. So now we have converted this from a logarithmic form to an exponential form. Now what we can do is we can notice that we have a 1/2 here on this side, and I have a 32 that can be written as a power of 2. So I'm going to rewrite this problem, and I'm going to make this a 2. So instead of a 1/2, I'm going to write 2, and I'm going to say negative answer. So what that's doing is it's saying that 1/2 is 2 to the negative 1, and I still have the exponent that we wrote there is the word answer. And then the 32 is going to become a 2 to the 5th power. When we do that, we can now see that the base of each side of this little exponential is the same. And if it's the same and it's an equation, then our exponents had to actually equal each other. So we can now see that a negative answer equals 5. So our answer is actually a negative 5. Now we're going to do a lot more with this, so don't worry too much if that seems a little bit confusing. I just want you to have something that you can go back and reference. So we can take a look at another version. I can take a look at this natural log of e to the 3x. So now I'm going to rewrite this so that ln, I want to rewrite this as log base e, and then I still have e to the 3x. I'm going to set that equal to answer, and then I'm going to switch again. The base of the log will then raise to the power of the answer. So e to the answer is going to equal, I'm going to come back around, and it's going to equal all of this will equal e to the 3x. And now you can see I have an e as on the base on each side, so my exponents have to be the same. So my answer for this piece is 3x. Now, I can do the same thing. I'm going to do one more here, this log base 6 of 216. I'm going to go ahead and I'm going to also set that equal to an answer so that we can just rewrite this. So we're going to do our little switcheroo. I'm going to have 6 to the answer. And then I'm going to come back around, and that's going to equal 216. Now, these don't match, just like they didn't match on the first example we did, so we're going to rewrite this. I don't have to do anything here. So I'll have 6 to the answer equals 6 cubed, and now I can see these are the same. The bases are the same, so the exponents are the same. So my final answer is going to be 3x from right there, and this 3 from right there, and then the original minus from up here goes in between, and that would be our final answer. Now, I'm going to skip over the working with change of base. Right now, we just want to work on getting comfortable without a calculator. The last thing I'm going to look at is finding inverses of our exponentials and our logarithms. Now, I didn't mention it in this video, but from your Algebra 2 days, you should be able to know that a logarithm and an exponential are inverse operations, which is why when we were up here, we had a logarithm, and when we rewrote it, it turned into an exponential. Okay, so these are inverses of each other, just opposite operations. So down here, we're going to practice more that moving between our forms and see how we can rewrite these in their inverse form. So what we're going to do, just like we would normally do with an inverse, is we're first going to remind ourselves that this is the same as a y, and we'll switch our x's and y's. So this will become, and I'm actually going to write, actually I'm not going to do it on this one quite yet. I'm going to first say x equals 2 times 10, and it becomes y plus 3. Now, to convert this to its logarithmic form, because it's in an exponential, my new equation is going to be a log. I first need to get rid of the 2 that's on the right-hand side, so I'm going to write this as a 1/2 x. There's a temptation to write this as an x over 2, but I'm going to tell you don't do it, because it's going to confuse us on some things later. Now, at this point, I want you to draw a little line on your paper so that you can see that the 1/2 x and the 10 should be sitting pretty close to right there on that line. I'll even make mine look a little better, and the y plus 3 should clearly be an exponent. Now, we're going to switch our form. The base of an exponential will now become the base of the log, just like up here, the base of our log became the base of an exponential. It's got to move back and forth. Once a base, always a base. So now I'm going to grab this base and I'm going to go under just like I did before, but I have to move to the other side. So this is going to become log base 10 of 1/2 x. Now, I should be able to draw a nice line here and see that the log and the 1/2 x sit on the line and the 10 is a subscript. Then it's going to come back around and it's going to equal, I'm going to continue my little line here, and it's now going to equal y plus 3. So everything is on the line except for the base of that logarithm. Our last thing to do is to move the 3 to the other side and write it with its inverse notation. So I'll have f negative 1 of x for my inverse equals, and I'm going to say negative 3 plus log, and now I'm not going to write that base of 10 since I don't have to, and I'm going to say just log 1/2 x. So that would be my inverse. Okay, now I'm going to do one more. We're going to go the other direction, and again, we are going to practice a lot of this in class. So first I'm going to switch that to a y, and then I'm going to say, okay, x equals 3 minus log base 2 of 6y. We're going to go ahead, we're going to draw our line just so that we can clearly remind ourselves everything is sitting on the line, same font size, except for the subscript of the 2. Now, I'm going to do a little something different here. Since I have this negative log, I'm going to take this whole log and move it to the left, and I'm going to take my x and I'm going to move it to the right. And I'm going to give myself a line here in the beginning to start with this. So I'll have log base 2 of 6y equals 3 minus x. Now, let's find the base of the log. Everything focuses on that base. So it's going to become 2 raised to the 3 minus x. I'm going to give myself a line for my next step. So it's going to become 2 raised to the 3 minus x power. Sorry, I did not mean to write 3x. 3 minus x equals, I'm going to come back around, equals 6y. So my last thing to do is to divide both sides by 6, or what I want to think is multiply by a 1/6. So my final answer here is going to be, let me scooch this over a bit for us. My final answer is going to be f negative 1x, our inverse notation. And I'm going to write this as a 1/6 times 2 to the 3 minus x. Now, just as a quick note, the reason we're writing this as a 1/6 times 2 and not a 2 divided by 6 is because we want to be able to separate the base of the exponential and this coefficient. We want to be able to see those separately because it will help us when we go to graph. Okay, this was a lot of information in this one video, and we are going to do more practice in class, so make sure that you jot down any questions on any parts that you felt were confusing for you.